And in our last section, we're going to talk about some special polynomials. So these special polynomials will all have a very specific form, either in their question or in their answer. So let's do some expansion to start seeing if we can see some patterns. X by x is x squared. X by -3 is -3x. Positive 3 by x is positive 3x. Positive 3 by -3 is -9. If you combine your like terms, you'll notice that a -3x and a positive 3x actually cancel off, leaving you with an x squared subtract 9. If we expand in the second one, 3x onto a 3x and a 3x onto 5, we have 9x squared, a positive 15x, a 5 or -5 onto a 3x is a negative 15x, and a -5 onto a positive 5 is a negative 25. We get a 9x squared subtracting 25 because the 15 and negative 15 cancel off. So what is our pattern? Well, when we look at our factors, when we look at our answer, factors, answer, factors, answer, we're going to notice a few different things. For example, in the factors, you can see that one is an x add 3 and one's an x minus 3. One's a 3x minus 5 and one's a 3x add 5. So one is addition, one is subtraction. There is a specific term for this. They're called conjugates. And that's exactly what it is one's addition, one's subtraction. Notice that the first term, though, is the exact same thing. 3x, 3x, x, x. In the answer, there's a few more things to notice. Both the first term and second term are squares. This is a square. 9 is 3 squared. 9x squared is 3x and 3x. 25 is 5 and 5. So both terms, actually make sure that everything's right. Both terms are squares. But there's one other thing to note. Is that there's a subtraction between both of them. It's a difference. The specific name for these two things is a difference of squares. So what we're going to do is we're going to learn how to factor a difference of squares. So how can we go from this question to that answer, or this question to that answer? And the key is actually looking at the fact that they're both squares, and there's a difference, as well as there's addition and subtraction. If we want to look at the question between x squared minus 9, well, if you find out the square root of x squared, it's x. The square root of 9 is 3. One's addition, one's subtraction. The square root of 9x squared is 3x. The square root of 25 is 5. One's subtraction, one's addition. We can do the exact same thing here. The only difference is we have different numbers. The square root of 81, square root of 81 m squared is 9m. That's going to go in the first spot. The square root of 16 is 4. Now you just say one's going to be addition, one's going to be subtraction. You don't need any more work than that. Actually, you don't necessarily even need this work. You do not need to write it positive then the negative. You could write it the negative and the positive. Next one's a little bit trickier. 63 is not a perfect square. Neither is 28. But there is a greatest common factor. I cannot emphasize enough that your first step to factoring is always finding the greatest common factor. I cannot emphasize that enough. The greatest common factor between 63x squared y squared and 28y squared, well, first off, 7 can be factored out, as well as a y squared, leaving us with a 9x squared subtracting 4. The easiest way to identify a difference of squares is that we have a square subtracting a square subtracting a square. That 7y squared stays out in front. We're going to make 2 sets of brackets. Square root of 9x squared is 3x. That's going to go in the first spot. Square root of 4 is 2. And I'm just going to emphasize this a little more with more color. One's addition, one's subtraction. And there's a difference of squares. That is one of the key ones that you do need to know, especially going forward. The other two are just a little more fancy. So for example, if we want to factor this one, well, it's a trinomial. The difference between factoring the different squares and factoring simple or complex trinomials is the fact that a difference of squares only has 2 terms. It is a square subtracting a square. There is no middle term, because if you look at it, those terms actually canceled off. This one goes back to simple factoring. So x squared minus 8x plus 16. We find out our product and sum. Product of 1 times 16 is 16. A sum of negative 8. The two numbers that would have a product of 16 and a sum of negative 8 are negative 4 and negative 4. It's simple factoring, so we're all set. Just put an x in the first spot. Negative 4 and negative 4. The only reason that this one is a special type of factoring is because we have the exact same thing, which means it can be condensed to look like that. It's x minus 4 squared, because it is x minus 4 multiplied by itself. There are 2 x minus 4s. And that's done. The last one is the last kind of tricky thing. And it does play into effect with the fact that we have an x to the power 4 and x squared. Well, our work for here is really not going to be any different. I don't do a lot of emphasis on this, but it's still something that you do need to know. It is still going to be a simple factor. The only difference, though, is we don't have squares. The only way that this is going to work, the only reason that we can keep on going with the exact same method is because we have a 4, a 2, and a 0. Notice how this is literally double the size of this one. This one, and this one. 2 is double the size of 1. 4 is double the size of 2. And then we don't have any variable there. So the method is still going to follow the exact same kind of thing. We're just going to do one more, or a little bit more work after. Our product is going to be 1 times 36, which is 36, a sum of negative 13. So our two numbers that would have a product of 36 and a sum of negative 13 would be negative 9 and negative 4. So when we factor, it's going to look a little bit different. The only thing that's going to be different is the fact that this is an x to the power 4, which means our first position is actually going to be an x squared. For the simple reason that x squared multiplied by x squared is x to the power 4. We still have to put in our negative 9 and our negative 4. But we can go one more step. This is not finished because we have a square subtracting a square. We have a square subtracting a square, which makes both of these difference of squares. X squared minus 9 will factor into an x add 3, x subtract 3. Square root of x squared is x, square root of 9 is 3. One's positive, one's negative. The square root of x squared is x. Square root of 4 is 2. X and 2. One's positive, one's negative. And we've learned how to do some more special factoring. So just be cautious that if you can go further, you do have to go further. Okay? So go have fun.